Now, just to go through Newton's laws of motion, they really explain forces and explain an awful lot about how things move and how things work. Now, the first law, I've only taken it down in very shorthand. I've left really important things out that I'm going to fill in. Now, the body will remain at rest unless acted upon by an external force. That's pretty obvious. If something is still, it'll remain still unless it's acted on by an external force. So that bit is fairly self-explanatory. What's interesting about the first law, though, is there's another part to it that I'm going to fill in. So a body will remain at rest or continue moving at constant velocity unless acted upon by an external force. Now, this line here is crucial, this little part of it. The reason being is that what we're explaining is that if you set something off, it'll remain at that constant velocity unless it's acted upon by a force. Now, this is probably the apple falling off the tree and hitting him. I think that's probably where this law is related to that. Now, it means that basically we are constantly under the force of gravity on our planet here on Earth. So if something is moving at constant velocity, gravity acts upon it, and also air friction and friction will happen to it. So generally something moving at constant velocity requires extra energy to keep it going at constant velocity. What you have to imagine, though, is that Newton figured out that if you were in space where there is no gravity, if you were to set something in motion, it would continue on at that velocity unless acted upon by an external force. Now, I've left out one other word here that it's quite important as well. It has to be an unbalanced external force. And the reason why it has to be unbalanced is because if you were to tie two strings to something and pull equally in opposite directions, that object would obviously not move. So there has to be an unbalanced external force in order to change the velocity of a body. So that is a very important, and particularly what's important is to continue moving at constant velocity unless acted upon by an unbalanced force. Now, the second one here, and I've written it out in full, so the rate of change of momentum is directly proportional to the applied force and takes place, and I've just left that little bit out, in the direction of the force. So force is obviously a vector as well as velocity. Now, this in equation terms, and I'll just write it out. So we have F is proportional. That's the symbol for proportional. That means if I'll just put it to the rate of change of momentum. So that's the change in momentum over the change in time. Now, much as acceleration is the change in velocity over the change in time. Now, we're going to do a little link here with this. So F is proportional. Momentum is given by m is equal to momentum. Let's put it. Momentum is equal to mass times velocity. So this is equal to mass times final velocity minus mass times initial velocity over the change in time is just time. Now, the next bit here is we can just factorize out the m out of that. So we have m brackets v minus u over time. Now, if you remember back to our three equations, we've got one of them was v is equal to u plus at. Rearranging this, we can see that a is equal to u minus v minus u over t. So instead of that, we can write this out now as force is proportional to mass times acceleration. So this whole bit here we can write as acceleration. Now, because these are proportional, there's some constant you can multiply by it that will make them equal. So we say that force is equal to ma multiplied by some constant k. And for physics, it just was decided to let k equal to 1. So force is equal to mass times acceleration. Now that's probably the most common form of the second law of Newton's second law of motion. Force is equal to mass times acceleration. Now that's quite an important little derivation, and if you just learn that off completely, you'll always get it right. The final law then is that for every action there's an equal but opposite reaction. This could be demonstrated with a number of things. So what it means basically is that if for a rocket to move forward, to move up, it also has to propel something back in the opposite direction. So those three laws have to be learnt, they have to be understood. The one that's most used in sums in problems is definitely the force is equal to mass times acceleration. But you have to know the wording of the law as well. The rate of change of momentum is directly proportional to the applied force and takes place in the direction of the force. And you have to be able to derive F is equal to ma and show that they're equivalent. So that's it.